All right, this unit is about polynomials. Let me autofocus. Poly should remind you of polygon. Back in elementary school when you learned your shapes, poly, remember, means many, and nomials means like numbers, numbers or terms. So you guys have been working with polynomials and you just didn't realize it throughout the whole entire school year. So to refresh your memory on something to get ready for adding and subtracting polynomials today, you have to remember how to combine like terms. So write this down, combine like terms, and here's your first problem that I want you to take about 30 seconds to write it down and go ahead and simplify it. Okay, hopefully you remembered that 9x and negative 5x were like terms. When you add 9 and negative 5, you should have gotten 4x. And then you added 15 and negative 6, and you get positive 9. So you're just combining like terms, and you're left with 4x plus 9. You don't solve anything. There's no equal sign. You're done. Okay, I'm going to go ahead and go ahead and push pause, and you need to work these two out. Should take you maybe 2 minutes after you write them down and actually combine like terms. All right, hopefully you have pushed pause and you have solved them out. You should have combined 8a and negative 10a and gotten negative 2a. Then 5 and negative 11 is negative 6. All right, on this one, you combine your a's together. Negative 13a and negative 15a is negative 28a. Your b's together, 12 and 2 is 14, so you put plus 14. And then 21 and negative 5 would be 16, so plus 16. You could have had the a's and b's in different order. All right, so this is what we're getting into today. A little bit different. You've got exponents in there, so I want you to try it before I go over it. So again, push pause and just try. Not one student so far has gotten this right, so see if you can do it. Okay, hopefully you push pause and you tried it. Most students, what they're doing is you're adding everything that has an x together and including the exponents. And that's actually not correct because these exponents mean different shapes or different things. So when you see an x, that would be represented like a rectangle because it would be x units by 1 unit. X times 1 is x for an area of x. So to visualize it, your x's would be rectangles. So when you add your x's together, you should be adding all of the rectangles together, and you have a set of rectangles. If it's x squared, it's x units by x units, so x times x is x squared. If it's x to the third power, it means x times x times x, remember, so the shape of that would be like x times x, times, it would be three-dimensional, so it would be like a volume. X times x would be x cubed. So if you visualize it like shapes, then it helps you remember to combine the correct or like terms. So I'm going to start with my cubes. These would be cubes. This would be a cube. You don't have to draw the shape unless it helps you visualize it. So you have negative 2 cubes and a positive 1 cube. Okay, I know some of you are having a hard time with your negatives. But if you have negative 2 plus 1, that would give you a negative 1. So you would have negative 1 cubed. So it'd still be x to the third power. You don't do anything to the exponents. They're just combining like terms. If you put a group of cubes together, it's not going to change shape, so your exponents won't change. Okay, now let's go to our squares. X squared and x squared. So you have 3 and you have 2, so you have a total of 5. Okay, and then we have our x's. Negative 4 and 6 would be 2 x's, and then you have just a 4. The reason I'm writing them in order is because when you write your answer, you need to write it in order of biggest exponent to smallest or no exponent. So you would write your answer out like this. If it's a positive 5, you put plus 5. If it's a positive 2, you put plus 2x, and then if it's a positive 3, you put plus 4. If it was negative, you would put minus. So that would be your final answer. Okay, I'm going to give you a few more to try. Okay, you need to write those down on a piece of paper in your notebook. You need to try them. I'm only going to walk through about 2 more of them. So I'm going to talk about the last one only. The rest of them you need to try on your own. So I'm going to pause it now, and I want you to do the same and write them down. Okay. The last one, the reason I want to go over that one is because it's a little bit different, because you have A, B's, and you have just A's. Well, these 3 would actually be your like terms, because they all have an AB. And then these 2 would be your like terms because they both have an A squared. So when you add negative 1a squared and negative 3a squared together, you get a total of negative 4a squared. Again, the exponent does not change. You're just combining your like terms, so you're just adding coefficients. The terms stay the same. You have 1ab, 8ab, and negative 5ab, so 9 and negative 5 would be 4. So you put plus 4ab. Okay, I want you to go ahead and try the first one if you haven't already. Okay, hopefully you combined your x squareds. I always go with the biggest exponent first, so then I know my answer is in correct order. 5 and negative 4 would give you 1, so you can just write x squared. You can have a 1 out front of it. And then 18 and 1 is 19, so 9 plus 19x. Alright, I'm going to pause it and let you finish to the next 3, and I'm not going to be going over them on the video. You'll have to get them checked in class. And I'm going to introduce you to adding and subtracting polynomial. Okay, that should have been plenty of time. Alright, this is the handout that you should have gotten in class. The rest of it you should have written on a piece of paper. So we are going to be adding and subtracting polynomials. The top half is adding, and the bottom half is subtracting. Alright, sorry. Hopefully you had time to work on the other one. So you fast forward, that's fine. Okay, so we're going to be adding polynomials, the top half and the bottom half subtracting. So the reason why there's parentheses around this is saying that this polynomial plus this polynomial. So it's like, you're going to add this one plus this one. So remember, it's like having an imaginary 1 outside of the parentheses. So you're going to distribute that 1, and then you would get 5x squared plus 2x minus 1 plus 4x squared minus x plus 2. And now you just combine like terms. I'm going to pause it for you to go ahead and do that. Oh my goodness. Okay, I'm going to have to start this video over.